we know that in quadratics that the roots, the solutions, the zeros, and the x-intercepts all mean the same thing. Meaning, if you have a graph of a quadratic, in other words, a parabola, then these, where they cross the x-axis, are the solutions, or the roots, or the x-intercepts, or the zeros. Okay, and right down the middle of the parabola is the axis of symmetry. And if you notice, it splits the parabola in half, which means that this root on the right side is the same distance away from the axis of symmetry as the root on the left side. They're basically the same distance apart from the axis of symmetry. And that's important to know because when you do the quadratic formula, then it helps you understand what the quadratic formula is. And the quadratic formula, use my finger here, because it's x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. You're going, oh my goodness, what does all that mean? Well, if you remember, the standard form for a quadratic is ax squared plus bx plus c is equal to 0. The equal to 0 is important. If it's not equal to 0, you have to make it equal to 0. Subtract that number on the right side from the c, and then that'll make it equal to 0. But there's your a, b, and c that falls into these things. Okay, a there goes right there, right there. B there goes right there and right there. And of course the C, do that in yellow, the C here is right there. Okay, so when you look at the quadratic formula, you think, my goodness, that's a big formula. I don't know how to use that. Well, now you do. Just plug in A, B, and C, and the answers pop out. The key part is this plus or minus right here. So you're going to get two different answers, two answers. Sometimes it's the same one, but you get two answers, the quadratic formula. And basically, if you split that fraction up, change it to the color you can see, x is equal to minus b over 2a, and then plus or minus the square root of b squared minus 4ac over 2a. This is the axis of symmetry. And all it's saying is that if you add this term on the right to the axis of symmetry, you get one root. And if you subtract, you get the other root. That's all that is really saying. Okay, so it's not too difficult to understand once you realize that. So if I have a quadratic, the minus b over 2a is this axis of symmetry. And when you add that term on the right, the square root of b squared minus 4ac over 2a, it gives you that root. And when you subtract it, it gives you that root. That's all that quadratic formula really is. A lot of teachers don't explain it that way, but that's really what it is. Okay, yes, it's a formula you kind of have to memorize if you're going to use it, but once you do, it's fairly easy to use. So let's go back to okay, so if we take the equation, the quadratics, so x squared minus x minus 12 is equal to 0. Okay, so the first thing, just write down what a is equal to, what b is equal to, and what c is equal to. And that way you have to bring their signs with with them. If you do it this way each time, then you don't lose the signs. A, now look what's in front of the x squared term. There's nothing, so A is 1. Now look what's in front of the x term, B, it's a minus, but nothing, so it's a minus 1. Now look in front of the C, or I look at the C term, it's minus 12. Okay, so 1, 1, 1, negative 1, and minus 12. So let's make some room here and rewrite that quadratic formula. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now we have to plug in 1 for a, negative 1 for b, and negative 12 for c. So let's do that. Make some room again down here. Okay, so minus b, we knew that b was negative 1, so minus negative 1 plus or minus b squared. Negative 1 times negative 1 is positive 1. So 1 minus 4 times a was 1, and c was negative 12, all over 2a. A was 1. Okay, so now if we look at start simplifying over here, this term on the left, negative 1 is positive 1. Okay, so this becomes a positive 1. And 4 times 1 times negative 12 is negative 48, but it has a negative sign in front of it. So it becomes positive 48. So 1 plus 48 is 49. So we get 1 plus or minus the square root of 49, and this is just 2. So let me make some room again. Simplify that. So we've got 1 over here on the left, 1 plus or minus the square root of 49 over 2. Square root of 49 is 7. So it's really 1 plus or minus 7 over 2. Okay, 1 plus 7 is 8, divided by 2 is 4. So x is equal to 4. And 1 minus 7 is negative 6, divided by 2 is negative 3. So this is telling you that the roots are 4 and negative 3. So if you graph that, it tells you the roots are 4 and negative 3. So 2, 3, 4, and 1, 2, negative 3. So the roots are 4 and negative 3. Because it was a positive x squared term, that means it opens in the up direction. That means it kind of goes down something like this and then comes up like that. That's all that says. And you know the axis of symmetry is halfway in between them. Okay, so the halfway point between 4 and negative 3 would be, looks like about positive 1/2. Okay, but if we just do minus b over 2a, we knew that b was negative 1 and a was positive 1. Negative 1 is positive 1 over 2. So the axis of symmetry is x is equal to 1/2. And that's it. That's the axis of symmetry. That's how you use the quadratic formula. And it's as simple as that. Now what you'll find is that when you have the parabola crossing the x-axis like this twice, you get 2 solutions. If it just comes down and barely touches, you'll have, when you do the plus or minus, it'll end up being the same number. So you'll only have 1 solution. And if the parabola doesn't cross the x-axis, you'll have what's called a complex number, which you'll get into when you get into algebra 2. But we won't do that for algebra 1. So that's that.